Station, this is Houston. Are you ready for the event?
Houston, this is Station. I'm ready for the event.
Explorers Club, this is Mission Control Houston. Please call Station for a voice check.
Station, this is Brandy with the Explorers Club. How do you hear me?
Hello, Brandy, and all with the Explorers Club. I read you loud and clear. How about me?
Perfect. Perfect, Commander Mir. Thank you so much. On behalf of the Explorers Club and our global fellowship tuning in from every corner of this planet, welcome to Dispatches from the Field. It is an incredible honor to have you joining us live from the International Space Station. To anchor us in your current orbital reality, walk us through the primary objectives of your mission and what part of that science is genuinely exciting you right now.
Well, our mission right now, we are part of the Expedition 74 crew, and then my crew that came up on a SpaceX Dragon will stay for a few months longer into Expedition 75 as well. This means we've had 73 and 74 missions prior on the International Space Station. As many of you may know, we have had a continuous human presence up here on the International Space Station for almost 26 years. The first module launched in 1998, and we've had a continuous presence since the year 2000, so pretty impressive. The main objectives for the space station remain pretty much the same from expedition to expedition, and that is to first, of course, maintain the space station. She's getting a little bit old by now, and so we have to do some preventative maintenance, some routine maintenance and repairs along the way. And perhaps most importantly, as you mentioned, the science. This is a world-class laboratory. It's a national laboratory as well up here, and we are constantly doing experiments ranging from material science, protein crystal growth, biology, cell biology, human physiology and medicine, material science, combustion science. Really every aspect, every field of science is represented up here. And I like to think of it, it's so exciting to me as a scientist because I like to think of it sort of as this elephant in the room. If you think about any system down on Earth, that system has had gravity present from the beginning of its evolution, if it's a biological entity, from the time of its onset for all the physical and chemical systems as well. So you can imagine, if you ask this question, what would happen if you remove such a major parameter? There are so many hypotheses that one can come up with. Just to give you a few examples of what I've been particularly excited about recently, we just had the SpaceX 34 cargo vehicle. It just departed us. It was here for about a month, and it brought a wealth of different scientific experiments. For me, particularly exciting because there were a lot of biology experiments, and I did a lot of those experiments right here in the Life Sciences glove box, which you can't see right now because it's kind of tucked into its rack, but it's a big glove box that extends out here, and I can stick my hands through these glove ports and then work in a contained volume to keep the science clean and safe, to keep us clean and safe from any chemicals that we might be using. We did some experiments looking at megakaryocytes and platelets, so looking at these different cells in our bodies that are important for blood clots. One thing that we have found rather recently is that some astronauts have developed clots on orbit, and we're not sure why this is happening, probably due to some of the differences in blood flow because of our upward fluid shift and microgravity. But we want to make sure we understand that so we can prevent it and make sure that we can treat it and keep astronauts safe. I also was doing an experiment with stem cells. Previous experiments have shown that stem cells are a bit more prolific up here. They divide for longer than cells on the ground do. And of course, we know that stem cells are incredibly important in various therapies, ranging from cancer treatments to many other disease states. And the hypothesis here is that these cells will be more prolific, and if we actually produce these cells, we used a very novel bioreactor up here that was able to give fresh media changes and keep those cells going, and the results have been very, very promising. So really cool scientific work, in addition with all of the different physiology and medical experiments. I could talk for an hour just on that, but I know we have a lot of other questions to cover.
Well, I mean, the breadth of the research that you're doing is just extraordinary. Now, given that this is your second long duration mission to the ISS, what did returning feel like? And has anything surprised you about yourself this time around?
There were certainly some surprises. Like I was just mentioning, the mission up here really remains relatively the same. So it's very, very familiar. There's not a lot that's totally new. There's even more stuff up here than when I was up here last time, and obviously I'm up here with a different crew. But I think the thing that has surprised me the most was I actually didn't know exactly how I was going to react the second time. For me, if you saw me during my first mission, I was smiling the entire time. I had this pure space joy and bliss from the moment I arrived in microgravity. I felt like I was home. I felt comfortable up here, and it just felt like it was exactly where I was supposed to be, and I was happy for that entire 7 months. But this mission, I'm in a very different place in my life. I have a 3.5-year-old daughter and my husband back on the ground, and I didn't have either of those last time. So to be honest, I was a little bit worried. I didn't know if being in such a different place in my life, leaving my young daughter at home for 7-8 months, like how that was going to feel. And I was a little bit worried that maybe it wouldn't feel as special the second time because it wasn't completely novel. But what surprised me and really relieved me, I guess I'll say, is that I had that same pure space joy and bliss from the moment I arrived in microgravity again. We've been able to have a wonderful connection with my family. My daughter, even at a young age, has been very engaged in these video chats that we're able to do because we have even better connectivity up here now than we did on my last mission. So all of that was a little bit unexpected, really because I'm at such a different place in my life. And I know that that's true for all different types of explorers around the globe. Depending on where they are in their life, it can really affect that kind of expedition mentality.
And that gives the opportunity for you to be able to share that wonder with your daughter, which is one of the most extraordinary things that can happen. Now, from the cupola, what Earth observations have really stood out most to you on this mission? And is there a moment of looking down that has really genuinely stopped you?
Every view that we are so privileged to have up here is extraordinary, and things always look different, even if you're passing over the same spot, because the lighting might be a little bit different, the cloud cover might be a little bit different. And I mean, it's hard to pick just one favorite. The textures and colors of the sand dunes in Africa and in the Middle East are extraordinary to me, the coastal currents. But I think the one thing that really stands out to me that's different this mission are the aurora, the northern lights and the southern lights. We see those quite frequently this mission, and that's because on my previous mission, we were actually at a minima of the solar cycle, the 11-year solar cycle, and now we're actually at a max. And so we have much more intense northern and southern lights, and that has been extraordinary for me. Just a couple weeks ago, and I posted this on my social media accounts if you had the chance to see it, there was a solar event, a coronal mass ejection, and it produced this extraordinary array of southern aurora, and it was mind-blowing for me. I mean, it's very, very otherworldly, this ethereal glow and the green dancing and some red as well dancing around you. And I never saw anything like that on my first mission because we were at such a different point of the solar cycle. So really astounding views all around.
Wow. Now, let's shift it a little bit, Jessica, to your background. Before NASA, you tracked geese, you dove under Antarctic ice, you did field work in some of the most extreme environments on Earth. Now, how does that kind of terrestrial grit compare to the operational intensity of living in low orbit Earth orbit?
I think for me, I have found that I am really the most content and the most satisfied when I do something that has both a mental and a physical challenge. And I think that's the commonality for all these types of environments, these extreme environments that have really appealed to me, both in my previous career dealing with the physiology of animals in extreme environments like underwater or high altitude. And it's kind of a full circle moment for me where I went from working at NASA and facilitating science on astronauts before I was an astronaut. Then I was facilitating experiments on animals, and they were my subjects. And now it's full circle where I am the one being prodded in the name of science, and really, I think, paying my dues for all of that. In terms of grit, there is a lot of grit involved in everything that we do up here. I think the biggest one is probably spacewalks. We are getting ready to do a spacewalk next week. Chris Williams and I did one in March, and Chris and I will be doing another one next week. And it really, again, that mental and physical challenge, that is the culmination of the most intense mental and physical challenge that we have up here. And it does take a tremendous amount of grit, both mentally and physically, just like the types of exploration that I know all of you fellow explorers undertake as well.
This may be the perfect opportunity to really ask you if you could biologically redesign us humans for life in space, what evolutionary upgrades would you give us?
That's an interesting one. I crowdsourced this a little bit with some of my crewmates earlier as I was thinking about it. One of them is I think we would have some slightly different adaptations on our feet because as you can see, we don't wear shoes up here as astronauts. And if I need to keep myself in position like I'm doing right now, you can see my feet are underneath this little handrail and the tops of my feet are what I'm kind of flexing my toes and holding myself here. And so, our feet, we haven't evolved that way to be on the tops of our feet, right? It's the bottoms of our feet that get that thick sole and develop calluses from walking. So up here, we, have a little bit of sensitivity in the beginning on the tops of our feet, and we develop some of those calluses are on top of our feet as well. And so I think, maybe something about that. Maybe also something in terms of how we navigate three-dimensional space. There's still, even though our brain, the plasticity of the human brain is remarkable, and I can actually feel in the first few weeks of my first mission in space, I could feel my brain learning how to navigate in this 3D volumetric space. If you think about it on Earth, you're really only using like half of the volume that's presented to you because you have, maybe you put something down on a table and you're using everything from there and down to the floor. You're not using all of this upper volume near the ceiling. But up here in space, I might actually have to jump up here to this ceiling surface, what we call overhead, and I'm using all of this volumetric space. So I think that the human brain is remarkable and has a lot of plasticity that makes you much more comfortable with that even after about 2 weeks of being on orbit. But there's something about us evolving in gravity that kind of gives us this up-down type of mentality. So I think being able to adapt even better to this 3D volumetric lifestyle up here would be another advantage.
Oh my gosh, that is the best possible example of how we can really approach expansion. I know NASA maximizes every hour of your time up there. Has anything happened on this mission that was unplanned, unexpected, and what did it teach you that training never could?
We have unexpected, unplanned events happen every day. That's really just how things go up here. And those can be really minor ones, like I'm opening up a stowage note for an activity and the thing that is supposed to be stowed in a certain location is not where it's supposed to be, and now I need to look somewhere else. Those could be really major ones. You may have seen in the news that we've discovered some new cracks in the Russian segment of the space station, which of course eventually could lead to a depressurization, which would be a very big deal up here in the vacuum of space. So it's really just something that we have to be prepared for every minute, every second of every day. That's life living in this extreme environment demands that. And the lesson that teaches you, I think the strongest most important attribute that an astronaut can have is flexibility. And that's true for all types of exploration as well. I mean, that's why we're exploring. We're going into the unknown. We want to find the unexpected. That is what drives us. And so in order to operate with those kinds of conditions, you have to have that flexibility. You have to be able to react, to replan, to not get too set with your going in plan. You have to be able to be agile. And I think that's one of our most important skills as life up here on the space station.
Absolutely. You may be in one of the most profound areas of adaptability, but thank you so much for that example so that we can bring that home for us as well. Now, you gave us a little bit of an example of the expansion. Could you demonstrate microgravity for us right now?
I mean, you can't beat that. Being able to just spin around, shoot yourself down the module, it is endlessly entertaining.
You cannot beat that, and thank you so, so much. Um, you know, if you could design one experiment that has never been done on the ISS, what would it be and what would you hope to learn?
Oh, that is a difficult one. We have done so many different types of experiments up here, but I think some of the things that maybe one thing that I used to talk a lot about my previous mission when I was thinking a lot about that plasticity of the human brain, it was something as a physiologist that was so remarkable to me because I could physically feel it. You know, I would jump up to that ceiling like I was describing, and my brain, I could feel this flip flop of my brain interpreting this new position again as down, because on Earth, if you're in contact with something, it must be down. You know, we only have right and left because we have down relative to this velocity vector of gravity. And so I think for me, I just wanted to know as a physiologist what is going on in the brain. If we had, you know, an MRI, this would be a very difficult thing to do in space, but if you could actually get a brain MRI to see what is happening, some kind of portable system that an astronaut could have on and see what is happening, especially in those initial couple weeks of adaptation, I think it would be remarkable to see all of these new areas of the brain lighting up, and then to be able to compare that to somebody that's been in space before, to a rookie. You can see when somebody comes to space for the second time, they're much more graceful. Maybe it's been 5 or 10 years since they've been up here, but they have those new neural networks, those pathways that formed years ago that are just reactivated versus forming in somebody else for the first time. So I think it would be remarkable to see those kinds of images.
Thank you so much. Let me give you a final question before we let go. As a member of the Explorers Club and a proud member of the Texas chapter, you are living proof of where exploration can take you. What is your message to the next generation of explorers, and how do we, as a global community, pick up that flag and protect our planet?
I think my biggest message and what I learned from being up here and this privilege of looking down at the Earth is understanding the perspective that you gain from that. When you look down at our planet, you understand that we are all connected, that we are one human, and that we all are in this together. And I think that that lesson can be applied from so many different vantage points to understanding climate change and how to protect our planet, to understanding the drive and the need to explore further. So I think that's my big message. You know, as humans, we can easily get caught up in the minutia and the small problems or details that are in front of us at the moment and kind of forget to reframe and take that perspective shift back. So I would say keep exploring, and most importantly, keep communicating, because if we aren't able to communicate what we are doing, and I know that's such an important part about what you're doing today and in your job on the ground, if we can't communicate it with people around us, then instead we will just be siloed. So I think that that is absolutely vital. Keep on exploring, keep discovering, keep communicating, and keep waving that flag proudly.
Commander Mir, you are floating 250 miles above us, circling this planet every 90 minutes. And in the middle of all of that, you gave us your time and your mind and your heart to every one of us watching today. That is the spirit of exploration at its finest. On behalf of the Explorers Club and on behalf of every curious human being on this beautiful pale blue planet below you, thank you. Thank you so much. Not just for the science, not just for the mission, but for reminding us of how capable we are when we refuse to stop looking up. Safe skies, Commander. We will see you when we get home. When you get home. We can't wait to see you when you get home.
Thank you so much, Brandy. It's been a pleasure. As you can see, I have some mementos up here with me, and the flag is not here yet. It was delayed because of some changes with cargo vehicles, but it is coming, and I do have word that I will have that flag up here to wave proudly with me before I leave the space station, so stay tuned.
Station, this is Houston ACR, and that concludes the event.
Thank you to all participants. Station, we are now resuming operational audio communications.